This chapter is going to be on liquids. Okay, so when we look at a liquid, we're going to talk about the pressure that liquid can exert on things. And the pressure is going to be the amount of force it exerts over a certain area. That metric unit's called a Pascal, and that's going to be 1 Newton of force for every square meter it's exerting that pressure on. Atmospheric pressure is about 1,000 pascals, so that's what we're used to here. All right, so let's look at force and pressure and all that. We have a gold brick and it's sitting there. It's 12 kilograms. We know that's 120 newtons. Remember that. Just you multiply it by 10, force of gravity. Then we take the surface area of that, and they give us the measurements there. They give us the surface area, and they say the pressure on that surface is going to be 120 newtons on the 0.02 meters squared where it's resting. That's the pressure applied. Whenever I think of this, I think of pounds per square inch, which is, the American way. But I think of my cat walking on me. It's not that they weigh a lot. It's just that they have little tiny paws. And when they step all over me, it hurts because all that weight of that fat cat is on that little tiny paw stepping on me. Okay, so look at these again. You have the same weight spread out over a surface of A. What's the pressure going to be versus B? Again, think of my cat. What's the pressure going to be on that little tiny surface? It's going to be greater on that little tiny surface. Okay, then when we look at this, where's the greatest pressure? Well, when we look at it, this pressure here, the one between these blocks, is going to be the same as the pressure down here. But as we multiply these forces, it's going to be 3 times by the time you hit it down here. Okay, this is just another way of doing this. But the surface area down here is a lot greater, so you have less pressure here, and the surface area over here is smaller. So again, the pressure is going to be greater over there. Okay, no, again, I am not doing this. I know they recommend it, but I'm not going to do this. In this lecture, they actually show you the math here. If you weigh 150 pounds, there's 300 nails. That's a half a pound per nail, but you need 5 pounds of force to pierce the skin. I am not going to try that for you. Don't even think about it. All right. You don't have to write this down, but if you hold a cup and you poke some holes in it, the bottom hole should go the farthest just because the pressure is the greatest. Same as the brick. Remember low, medium, high? Yeah, no problem. Buoyancy. Buoyancy, when we talk about pressure, it actually exerts in all different directions. We always think of it like it's pushing down, but it's not. It actually collapses things in every direction. So I think I told you guys about a tank that they accidentally drained upside down and they didn't pop the top lid and all the liquid came down and that tank collapsed in every direction because of atmospheric pressure. It doesn't collapse bottom to top, bottom down. It doesn't squish like somebody stepped on it. It completely collapses because the air pressure is in every single direction. So as you go down, you think the buoyant force is going to get greater and greater and greater. Well, the pressure gets greater, but the buoyant force doesn't, okay? Because you've displaced a certain amount of water, and that's what's causing you to want to rise. But there's also pressure down on you the farther down you go. All right, Archimedes. We love Archimedes. Here's the principle, is that if you float a water, the amount of water displaced is equal to the buoyant force on the object. So if it displaces a lot of water, then the buoyant force is great. Something very voluminous would displace a lot of water. It would have a lot of buoyant force. Something very dense and heavy that doesn't displace a lot of water isn't going to have a lot of buoyant force. Maybe that's going to sink. Okay. So take a demo. We're not going to do this, but it's an example. You have a kilogram mass submerged in water. It displaces 150 centimeters cubed. That's the volume. So then you figure out, well, the water displaced would be 150 grams because the density of water is 1. For every 1 gram of water you have, it takes 1 centimeter cubed. So the buoyant force, the force that's lifting that up, is 150 grams. If it weighs more than that, it's sinking. Okay, so let's look at this. What would happen if we put a wood block on a scale and we stuck it in the water? What's going to happen? I have 50 newtons on the left scale and into that 50 newtons, I place a block and 10 newtons of water spills over the edge. Okay? How much does that scale weigh? Answer is it still weighs 50. All right, so just like in the one before us, does this have to take into account the weight of the boats or the weight of just the water? And we know the boats are going to displace as much water as they weigh, so it's all good. I just think it's a really trippy picture. Okay, and we don't have to, you don't have to write this down. This is an example that you can float something, and this is just a really dense liquid. So it's displacing as much mercury as it weighs. It's just that mercury happens to be really dense. If you can see, it's actually floating in a cup of mercury, not water. Okay, I don't want any comments on how bad Diet Coke is for you. Ships. So we think, well, wood is very, very, not dense, but iron is so dense. How could it possibly float? Well, the answer is it displaces more water than it weighs, and it does that by being hollow inside. If it's not hollow inside, it ain't gonna float. All right, hydrometer. You don't really need to know this, but in wineries, they use this a lot. It floats higher up and the more denser the liquid. Well, sugar is a very, very dense liquid. So if we want to know how sugary something is, they did it in salt here, which will do it too. But in the wine industry, it's in sugar. And if you want to know how sugary something is, you can use a hydrometer. It will tell you the alcohol content, because it'll tell you how sugary it is. The sugar turns to alcohol. It's all good.